So the final technique for limits, for solving limits that we're going to look at is called the squeeze theorem. So the squeeze theorem, first let's just go ahead and state the theorem. Okay, so this says let f of x, g of x, and h of x be defined for all x not equal to a over an open interval containing a. So again, it needs to be defined immediately to the right of a, immediately to the left of a, not necessarily a itself. So setting us up for a limit. If f of x is less than or equal to g of x, which is less than or equal to h of x, for all x not equal to a in an open interval containing a. We have to write this every time because, as we saw, we have cases in the last video where this is important. And the limit as x approaches a of f of x equals L, which equals the limit as x approaches a of h of x. Okay. Where L is a real number. Okay, so it's not infinity. Then the limit as x approaches a of g of x is equal to L. Okay. So two main conditions here. Okay, so you have this g is between f and h, right? And then the limit of f and of h is both, for both of them it's L. Okay. Then the one in the middle, the limit is also L. Okay, so this is why it's called the squeeze theorem. G is squeezed between f of x and h of x. You're taking the limit of f of x and h of x, and those are both going to L. So that's kind of squeezing G to be getting closer and closer to L, essentially. Okay. So if you go looking for an example of this, you're mostly going to find examples that have to do with trigonometry, the trigonometric functions. And this is because the trigonometric functions are bounded by, specifically sine and cosine are bounded by 1 and -1, right? So they're kind of set up nicely for these kind of problems. So for example, I'll just kind of skim through the details here. Because as I've mentioned, we don't really need to look at a lot of trig here. But one that we did look at the graph of was sine of x over x. And specifically at 0, this is undefined, or I should say indeterminate, right? Sine of 0 is 0, x is 0, so we get a 0 over 0 form. So you can show via basically just like drawing some triangles that this is less than 1 over cosine of x, but greater than, and I should say less than or equal to and greater than or equal to cosine x. Okay. Now cosine of 0 is 1. So if you take the limit of all of these parts, really, you should take the limit of, if you want to be proper with this. So let's kind of squeeze it in here. On the left you get 1. On the right you get 1 over 1, which is 1. So this tells us that 1 is less than the limit as x goes to 0 of sine of x over x is less than 1. So this will imply that the limit as x goes to 0 of sine of x over x is also equal to 1, right? And again, I should have those equal signs in there. So again, this is almost always used with trig functions because of these bounds. Maybe an easier one to see where, we can actually do without drawing some triangles to prove it. Sine of x over x is like the canonical example of this theorem. But let's go ahead and do this one, which is a little bit easier. Okay. So the limit of as x approaches 0 of x times cosine of x. Okay. So this limit, if we plug it in, we'll just get I guess you don't really need to use the squeeze theorem here. You could just use direct substitution and get 0. But it's usually kind of proper to show with the trig functions that this does indeed work. Just because these are kind of special functions, so maybe we don't want to rely on direct substitution. Okay. But anyway, so the idea is that cosine of x is less than or equal to 1 and greater than or equal to -1. So if we multiply everything on every side by x, and we should really technically kind of do the absolute value of x, but it doesn't really matter if you flip the signs, right? It would just, everything would still end up the same way. So anyway, so we'll have negative x is less than or equal to x cosine x is less than or equal to x. Now the limit, let me just write it over here, I guess. The limit as x approaches 0 of negative x is 0. The limit as x approaches 0 of x equals 0, right? So essentially this one's going to 0, this one's going to 0. So that implies that the middle part is also going to 0 as x goes to 0, right? So that implies that this is equal to 0. So x cosine x is bounded by x and negative x. So the and the limit of those two sides is 0. So the limit of the inside part is 0 via the squeeze theorem.